Yeah, we're live. 6:54. So technically I'm early. Tonight I want to talk about a 900 horsepower big block buildup and whether or not you would rather try to get that sort of power level with a naturally aspirated combination or one with boost. Spoiler alert. I think we should use boost. And I'm gonna tell you why. I'm gonna tell you about the dyno results of one that we did. We did a blown big block that made a little over 900, and quite honestly, it's all fairly simple. And not only that, it's 900 horsepower and pump gas, which is fairly easy to do, particularly when you're talking about forced induction. And in my opinion, we did it in terms of forced induction. We did it with the least effective, most difficult route. We used a big roots blower on it, which that's not to throw shade on the roots blower. It's just that if we did it with a centrifugal, we have less torque, and so less detonation problems, more efficiency. It's the charge temperature is going to be lower. If we do it with turbos, it's obviously, it's going to make more horsepower per pound of boost. So we do it at a lower boost level. We have an intercooler and stuff on it. And we can run an air to water intercooler underneath a 671 or 871. In this case, it was an 871. We can do that. But, a lot of guys don't do that. But we weren't running very much boost. And also on this application, because we had a big roots blower on it, we had two carburetors feeding that with lots of fuel going through it. You could, we ran gas. We just ran pump gas, 91 in this case. You could do that. Or if you had, E85 carburetors, that would be even better. And because you have fuel going through there at the boost that we were running at 7.5 pounds, the charge cooling that you get from the fuel is probably going to be enough to keep the charge temperature in line. It's not going to get very high at that boost level anyways, but it all worked out. So what I want to talk about is the route that we took to make this combination, and kind of also what you would see or what would be necessary to make it NA. So if you wanted to, first of all, we'll start with an NA combination. If you wanted to make more than 900 horsepower NA, particularly if you wanted to do it with the 496 stroker that we did, that would be a lot of power for an NA combination. You could do it, guys do it, but it would be 1.83 horsepower per cubic inch from a 496, which would require the following things. And this is why I don't think it's as good a combination. If you're going drag racing with it, it would be cool and it'd be fun, and it'd be a high winding 496, the big block, it'd be high compression, and a big lumpy cam, it'd have to have lots of cylinder head flow and stuff. And it would be cool. And it's one way to go. But I think it's less adaptable, less adept for street use, because the things that you would need to make that, first of all, if you wanted to make that specific output for a 496, you'd have to have high compression. It'd have to be a big dome piston and or a small chamber head to get the compression up there. Obviously, the higher the better. It's going to be easier to make more power. So it would be a dedicated kind of race motor thing or dedicated E85 thing, which is not a bad thing. You can get that up at pumps in a lot of areas. We can get that here in California. So that has potential. The other thing you have to do to get that kind of specific output on an NA motor is have a really big camshaft in it. So you're talking about something that's 270, 280, even high 280s at 50 to make that kind of specific output for a big block. So it's going to have a lot of camshaft in it with the attending valve train, lots of spring pressure, solid roller. It's going to have solid roller lifters, which is not going to be, in my opinion, a solid roller big block is not a great street driver, particularly if it's something that you put miles on, because I just don't think that they last as long. I know that we have some of the newer lifters that have, EDM holes in it and the oiling and all that stuff, but a solid lifter or solid roller big block, not what I would choose for any sort of street and daily driver kind of thing. That's just not what I would pick. So you have high compression, you have a very big camshaft, let's say. It's not going to idle very well. It's not going to drive very well on the street. The other option for you to, instead of the 496, you make it a 596 or a 632. So you go to an aftermarket block and more displacement. And that would make life easier because the specific output would come down. So that would be less of a problem. So you could get away with less cam timing, and all that would be, it'd be more expensive that way. but it would be better that way in terms of still making your power output, but coming down and improving the drivability, let's say. So you would need, regardless of what you do, you would need lots of cylinder head flow, which we had enough. We had Airflow Research 335s on this. You'd have to have good heads, probably better heads than that, to be in the 900 range. Maybe the 357s or something. You know, the more head flow that you can have for that, the easier it is to make that kind of power level and to make to make that specific output. You're looking at certainly a big single plane Dominator manifold and a Dominator carburetor, or a dual quad tunnel ram kind of thing, which is, you know, adds coolness factor and it adds power. So you can, you know, with a tunnel ram, you can certainly make more power than with the single 4-barrel. Not that you can't get to 1.83 horsepower per cubic inch with a single 4-barrel. You certainly can, and we've done that sort of stuff, and it works very well. It's just that, like I said, on a 496, that's more difficult. On an NA one, it would be a very high winding thing, big cam, lots of compression. Well, as we talked about, lots of head flow anyway. And then because it's a 496, the RPM where this thing is going to make 910 horsepower would be a fairly high RPM. So you might start be looking at things like, you know, titanium valves and stuff. And again, more RPM, more expense, all that. So you have to make all that happen. The way that we did it was different. So the way that we did it, we pushed the easy button by adding an 871 blower. That right away, that made our life a lot easier. So then doing that, it was just a much more conventional build. It was a 496, so a 4250 stroke crank and a 4280, I guess, bore size. It was a 30 over, 60 over Mark IV block. In this case. So we had a 496. We used a flat top piston with a valve relief, an intake valve relief, no exhaust valve relief. And doing that combined with the chamber size on our heads were 121, I think. This put the static compression under 9-to-1. So we had static compression in the 8s. We also had a decent sized cam. Actually, for street use, I probably would choose a smaller cam than this and then turn the boost up to offset that to get more drivability. You have the ability to do that on a blown application. We had good heads. We ran this thing both with Airflow Research 305 or 315 heads, and then also 335 heads, because they did a comparison with those two. And there's really no difference in power. The camshaft that we used was the BR300, which is a 255, 262 at 50. It is a solid roller, but it's a street profile, so it's a little less aggressive. Again, if I was choosing, we just chose it so that we could test these blowers really. But if this motor were built for a dedicated application, like I wanted to put it in my Chevelle and drive it around, or I wanted to put it in a marine application, which it's low compression, low boost, it certainly would be able to do that, as long as if we were going to do that and try to make that power, I would definitely come down in camshaft, particularly if we had an issue with wet exhaust or reversion or that kind of thing. But since you have more blower to play with, you know, you can come down in cam timing and go up in boost if you wanted to do that. As you came down in cam timing, more than likely it would go up in boost anyway, but you'd want to spin the blower faster. We spun the blower 1-to-1 on this one, and it made 7.5 pounds. And this was an 871 Wyand blower. We had two Holley. We ran two 950s on it, two 950 blower carburetors, and they worked great right out of the box. And we had an MST distributor on it. We had roller rockers on it. We had all the things. We had a good oil pan on this thing. And that's important on a big block. A lot of times what we'll do is, for the oiling system, we'll definitely adjust the oil level. And it's usually way less oil when running it on the dyno than they specify for that pan. Otherwise, we run into a windage issue, and more oil doesn't cure that problem. Less oil cures that problem. And so we can see that in the oil pressure curve while we're running it on the dyno. If there's too much oil and we start getting windage, the oil pressure actually falls off. As we take oil level out, we lower the oil level, the oil pressure curve gets better. And then when we start losing oil at the top, we know we've taken out too much, and then we put some more back in and go, okay, like this is the curve that we're going to get. and all of that works out very well. But the combination of enough cam timing in this thing, we had enough head flow, we had a blower that could supply this power level without any problem. The combination of the realistic, boost friendly static compression of less than 9-to-1 in the 8s, I think it was 8.8. That and the camshaft that we use, this thing easily ran on 91 pump gas and would run probably even better on, be a little safer on 93. Would be even better yet on E85, as we talked about. It would definitely make more power on E85. This thing ran a peak of 7.7 psi, which is not very high boost. As we said, carburetors doing charge cooling, doing their thing, that worked out good. This thing made 910 horsepower at 7.7 pounds at 6,600 RPM and 779 foot-pounds at 5,100 RPM. It had really good torque. I think we loaded this thing at 4,000 RPM, and it already had 450 or 450, had 750 foot-pounds there already, and didn't drop below 750 until 6,200. So it had, I would call an ample amount of torque. And on our load in, it was at 4,000 RPM, where we loaded this thing in. It was making 7 pounds there. It dipped a little bit down to 6.7 pounds. It had 4,800 or 4,700, but then was 6.9 to 7, and then only right toward the end, past 6,000 RPM, did the pressure start to increase. Went from 7 pounds up to 7.7 pounds. But the other thing is the power curve will still climb. We shut this thing off at 6,600, but at 6,500, went from 903 to 910. So we had 7 horsepower gain in the last 100 RPM. So this thing was still going up. And like I said, we were only spinning the blower at 1-to-1. So we had more blower speed, more rotor speed to play with. We could have run the boost higher, could have spun the blower faster. Could have certainly made more power, but a good combination nonetheless. And it shows that if you want to put something like that, this is a pump gas motor. It's 900 plus horsepower. It's got lots of torque. You could go spin the tires anywhere you want for this kind of combination. Or like I said, this thing could be put in maybe a marine application. So who doesn't want a 900 horsepower marine big block? And that's how to do it. So okay, would you pick a high RPM NA big block Chevy over a blown big block Chevy for your street strip Chevelle? And I'm going to add something to it for your, let's say, 900 horsepower street strip Chevelle. And there we have it. Let's see. Eric, Sneaker Kid, Jet, what's going on? 6'8". Dustin, can you run a turbo big block Chevy on pump 91? Yes, you can. This is the same thing. I mean, it's a blower, and we can run turbos on it. In fact, turbos would make more torque than this, I think, because although it'd be hard to get the boost curve any closer to 7 pounds, even with a wastegate, even with an electronic controller. So that actually did pretty good. But what you'd see is if we ran the same 7 pounds or 7.5 pounds with the turbos, what you'd get is more power, because you don't have the power consumption that's required to drive that supercharger at 900 horsepower, which is going to be a pretty fair bit on a Roots blower. I saw a book at the Barnes & Noble that was called 800 horsepower and pump gas or something like that. It was about building big block Chevys. How to wake up a 96 GMC 454. I have lots of videos up on that Gen 6 motor. I have cams, I have nitrous, we have boost, we have cylinder head changes and intake manifolds and all kinds of stuff. So there's lots of information, lots of videos I have up for that particular motor. I like that motor because it's a factory hydraulic roller, and it responds very well to things. And it's all of those Gen 6 motors are also 4-bolt mains, so they're good to start out with. Scott, you're gonna have to watch tomorrow. Richard, did you do an article on hot air intakes a long time ago? I have done several on them. My favorite one that I did, people ask me my favorite things a lot. My favorite air intake test that I did, which was the most elaborate of all of them, was something I did for Sport Compact Car way back. I did it in my Del Sol, and what we did was we ran all these 3 different air intake assemblies on, I don't think it was the Del Sol. I think it was the, I'm thinking that it was, I think it was another Civic Si that I had. And we had a short ram, like RS Akimoto deal, kind of I call them filters on a stick, just a length of 3-inch tubing and then a cone filter with a radius entry on it, but it's short. And then we had an AEM one that was long, that went down into fender well and grabbed cold air, but it was longer and smaller than the big tube RS Akimoto one. And then we had the factory air box. And what I did was we ran it on the chassis dyno and we demonstrated all the power. And we ran it with the hood open, which was very, very common back then. So it helped the open filter in the engine compartment. Then what I did is we measured charge temperature and then also measured top speed for the Civic in Mexico at our test site, at our top secret test facility. And we had, I can't remember if we had GPS or we had a radar gun. But we took top speeds, and while we were doing the top speed testing, we also measured charge temperature in the intake manifold. And not surprisingly, the hot air intake and by the way, the short ram, the filter on a stick one, the 3-inch short ram one, made the most power. And that's a resonance tuning thing that happens with these VTEC motors. The long one the long AEM one made the next best power. And then the factory air box made the least amount of power. When we ran them out for our top speed test, the AEM went the fastest. And then the factory one, and then the RS Akimoto one that made the most power went the slowest. And the reason that it did that, because it also had the highest charge temperature, because now the hood was closed. And even though we had a lot of airflow into this thing, because we were going fast, it had to be something small, because we were only going 120 something miles an hour. But even though we had airflow, into the engine compartment, it was still, the charge temperature was 25 degrees hotter, with that drawing air, in the engine compartment, the fans washing through there and stuff, grabbing that hot air versus grabbing air down in the fender well, which also what the factory one does. So that was my favorite test. I think it had the most amount of data and showed, real world. I don't know how top speed testing is real world, but it shows performance and like real performance, what's going on and stuff. And that the dyno, we can make power on the dynos, particularly on the chassis dyno with the hood open, you can look like a hero. But, because I did another test with that, with an open filter with the guys from Kenny Bell, I didn't go out and do a top speed test, but we just drove it around town. And, while you're driving and getting airflow into the engine bay, the charge temperature would come down. But when you would stop at a stoplight, the air temperature would skyrocket. It was it was awful. So then if you went to get on the gas from your stoplight, you would just draw in a bunch of hot air, which was not good. And then having one that has a dedicated cold air source made a dramatic difference in the temperature of the air all the time. Whether you were stopped or moving or anything, was always better. More air, more power, maybe a dual throttle body design. Is Farm Truck on a 632 still? I don't know what Farm Truck has in it now. Big blocks are a cheat code for power. Yeah. 9908 new valve springs, roller lifters, the bigger cam. I don't know what that's in reference to, Scott. I don't know what you're talking about. Keith, you're smoking 2 packs a day? That's not good. I'm not a smoker. Just letting the 454 breathe better with intake and carb or throttle body and headers. All of those things can help. Did the 871 have any special helix turns? No, it was just a YN 871, just your run of the mill roots blower. Had a Cadillac 514. It was 750 horsepower and 800 foot-pounds. (800 foot-pounds). It made more torque than it made horsepower. Steve Morris's boost fixes everything. He knows how to make boost, that's for sure. Todd, is there everything running good on that thing? Higher PMNA than Supercharger. So you want the best of both worlds. That's good. There's only so much horsepower you can strangle out of an LS motor. 21st century big block start at 540 cubic inches. None of the wrecking yard motors do, unfortunately. How do you get 900 horsepower to hook up? Yeah, I mean, you're not hooking up the 900 because that doesn't happen till the top, but you're trying to hook up 750 foot-pounds of torque, which is a lot. Never thought I would say this. I'm a turbo LS EFI guy, but I'm thinking of going twin turbo big block with the blow through for my next build, a 68 Camaro. That would be good in a 68 Camaro. You know, that kind of car I think deserves a big block. If you're thinking big block, that would work good. If it's a turbo, that would be your choice. I want to see the hot air intake test was on a Honda engine. Probably a 16. It ruined my dreams of running an intake on my Nissan Sentra. They work good as long as you get dedicated cold air. We did a lot of work when I was road racing the Del Sol. I did a lot of work on the air intake. It's one of the things that they allowed us to change. And so I made a setup like that RS Akimoto deal, but we housed it inside a sealed box that grabbed air from the fender well. So we got the best of both. We got cold air, but we also got, because for our road racing deal, we were never, except at the start of the race, which we did standing starts, which was really cool because we essentially got to drag race too. But we were, trying to always be in, post VTEC basically. Love my LS 6-liter Pro Charge and 6-speed. Yeah, that should be a good combination. Short ram supercharger adapter. I want to thank all that helped me out when I was fighting cancer. Happy to help, Todd. All these guys helped you out. I have a 548 with 12.5 to 1. Cranking static compression is 205. Cranking compression, okay. You think I can run 93 octane? The cranking compression doesn't tell you how much octane you have to run. or what water temperatures at what air temperatures? What does the chamber look like? What's the cam lift or what's the cam duration? There's a lot of things there. Richard, have you ever dynoed an L29 454 with a stock EFI and a turbo? I haven't done one with a turbo, but I have done a stock one with the EFI intake manifold. And we know what that does. What a surprise, colder, denser air is better. You would be surprised how many responses we got to that there's no way that one that makes more power could make the car go slower. Oh, Todd, your thing was a fuel leak? Fuel leaks are not good. polyhiram or Ford Cobra Jet intake manifold for Gen 3 and a Coyote Street Strip Mustang. I don't know. I haven't directly compared those two. My guess is the Cobra Jet would make more average power than a Hiram. I think I would use a hybrid booster axial centrifugal. Are you going to find those on eBay? What do you think about sniper intakes for a big block? You have to show me specifically which one you're talking about, because they use the sniper name for lots of different stuff. Blueprint 632 is plenty to twist the drive shaft of a 69 C10. First time my friend took it to the track, broke on the second run. Yeah, 632 should make ample torque. John, the Geo's doing good? We'll try to get over to see the truck. Todd, Alan's going to come over and see the truck. Cool. Shadow Ops, you got universal credits? Nice. So the 9644 intake and exhaust would wake it up until I can get a stage 2 cam. Would wake what up? Doesn't your 96 already have a 96 intake on it? And a turbo on a stock motor is just going to be what the stock curve is, just more of it. The factory EFI stuff, the long runner EFI manifold, made slightly more low speed power than a dual plane carbureted manifold did. But I don't think we tested the EFI with the camshaft change, but it would do the same thing. You know, it's designed for more low speed power than the dual plane is. But you just, with the turbo, you just elevate all of that. So with the EFI manifold and a turbo, if you get the turbo size correctly, it would, you know, it would be pretty torquey. Big block Chevy. What was that? That's not going to be a stroker. Here we go. Carbs versus EFI. Final EFI stock cam. Yeah, that thing made peak power at 4,400 RPM and made peak torque at 3,300 RPM with the factory EFI on it. I'm not sure if I'm doing something wrong. My friend has a single vehicle license. I wonder if that's the issue. Need to do it right. I don't know about how to do that stuff because I don't ever tune the factory stuff. Although I showed you yesterday, I did get this. So maybe it's time for me to learn. It's the Bluetooth one. Diablo Sport Predator X. 548 big block, 810 lift. That's like a real cam. 279, 288, 12.5 to 1, 119 TFS 365 heads, 5 dome, 93 octane work. Yeah, you can run 93 octane in that. I don't know how much timing you can run when you run 93 octane, but you can run 93 octane in that. Oh, you want to know if you upgrade the intake? We're talking about the air intake? I don't know if the air intake is going to do anything on that because I don't remember looking at how the mass air meter and stuff was configured in the truck. We take all that stuff off because we just get it from the throttle body to the other. All of that stuff is either already off or we ditch it. So I don't know about the air intake setup, not the intake manifold. I wouldn't change that if you're going to keep that. But headers on that thing would definitely help, and a catback would certainly make it sound better. I don't know how restrictive the factory exhaust is on that. Swapping a new 350 Chevy into my mud truck. I use a Vortec 350 since that's what I had, but I use the small valve smog heads and intake with an L-Rock AVS and an MSC distributor. Okay. I mean, the short block will take whatever heads you want to put on there. So my question is, should I have bought a Vortec carb intake so I could use the better heads? Well, you have to have the intake that matches the head. So whatever heads you have, you get the intake to match that. If later on you're going to get either way, if you're running two sets of heads, you have to have two intake manifolds. So if you're going to choose to do one, whatever head you're going to put on there, pick the corresponding intake manifold. There might be some intake manifolds that have both patterns, although I don't think I've seen that. I haven't ever owned a manifold that had both those bolt patterns on it. How's our poll doing? Would you pick a high RPM NA big block over a blown big block for your 900 horsepower street strip Chevelle? 50-50. It's half and half. Did you ever finish the 3800 Big Bang? No, I have not run that yet. I already have the Vortec heads. I was just being cheap. May buy one now. I don't think that those manifolds are very expensive. Yeah, $122 for an aluminum air gap intake manifold on eBay. $126. Yeah, that's pretty inexpensive. And the L31 heads, those Vortec heads would be good. You just got to make sure that you put the right springs or modify the spring pockets to put, and the guides to put enough spring in it so you have retainer to steel clearance for whatever kind of cam you want to put in there. You gotta make that big power. The Vortec heads are good, and they're a small chamber too. Can a stock 7.444 handle 100 shot of nitrous? Yeah, I have videos up where we ran nitrous on lots and lots of those. We usually did that carbureted. Just I would take the EFI intake manifolds, unless I was testing that specifically. We would take those off, and then we would run a dual plane intake manifold and like a 650 and a distributor on it. And then we would just put a plate of cheap, inexpensive Holley Sniper. We ran the Zex perimeter plates because we just ran whatever Westec had there available to run. So we ran a bunch of that stuff. But yeah, it'll take 100 shots all day long. .308 small block Ford steelhead. What is that? Is 308 the displacement? And are you looking for a Ford iron head for that? A recommendation? I need more information. I'll have to watch your Vortec build video. See what cam I can run. I know the Vortecs have self-lining rockers, but if I run, well, Jimmy, you won't be able to run a BTR cam because they don't make small block Chevy or big block Chevy cams. BTR only does right now. They only do LS, LT, Hemi. I think that's it. And they might be doing. They're also doing the Ford. It's the 400 plus inch Ford Godzilla motor. You're gonna have to pick a, if you're using the Vortec heads on a small block, you're gonna have to pick a low lift camshaft. Unless you modify the heads. That's one of the limitations of the Vortec heads. They flow pretty well and they make good power, but the way that they designed them so that they have a limited amount of retainer to seal clearance. So you have to machine the guide down or change the spring seat. Usually guys do both. Were you able to make 600 horsepower with a 6-liter with a fast intake manifold? We didn't when I did the intake test. It made 593 or 4 or something. How much power can I make with a stock TBI intake on the 96? Doesn't a 96, is a 96 a TBI? I thought 96 was the start of the Gen 6. Or their carryover years or something? If you have a Gen 5, if you have a throttle body injected one, a Gen 5, that's a different motor. That's a flat tappet cam, throttle body injected, dual plane intake manifold with a 2-barrel throttle body opening. It has a milder cam timing. It has peanut port heads. It's completely different than the motor I've been talking about. I might have to look on Marketplace for some 165 small chamber heads. You mentioned some LS cams you would sell last night. What about an XM284? I found the video with a centrifugal seems to make near identical power to a 274. Are an XE274 and XM284 are small block Ford or big block Chevy cams, and they're not LS cams? My 96 GMC big block dually was a Vortec. Would you recommend GT40P or GT40 for street use? I like the GT40s better than the P heads. Scrolling. I don't, Brandon, I don't have any big block cams, if that's what your question is. I don't have none of them. Yeah, I thought that the Gen 6 was 96 to 2000. But those are the kinds of cams that you should be looking at. I think for the big block, it's a 276, if I remember right. let's check, shall we? Computer-controlled flat tappet cams. Retrovit, extreme energy. I don't care about those. Mechanical flat tappets, no thank you. Are you really going to list your hydraulic roller stuff first? Wow. I'm surprised. 348, 409 cams. 409, 409. 47 swap cams. I know that they have Gen 6 stuff. Hydraulic roller. Yeah, so we have a 276, a 282, a 288 in the extreme energy stuff for the big block. And then extreme marine 284. Yeah, that's a 230, 236. Tracy, it's a sniper profiler intake for a big block Chevy. What do you think about these? I don't know. I have to see a picture of exactly which one you're talking about. 10.5-to-1 compression, 320 heads, hydraulic roller cam, 255, 260. I'll see if it comes up if I put that in. Sniper profiler. Is it made by Profiler or is it a Holley intake manifold? Sniper big block Chevy intake. That looks like a serious single plane. The Profiler one. It says sold out, but I've never run a test on that. Profiler guys are pretty good at what they do though. How better stock 302 valve springs? If you're talking about a 5-liter Ford 302, not very much. If you're putting a different camshaft in, you should change the springs. Would you ever do an 8-liter Viper Big Bang? I wouldn't do a Viper Big Bang. I would like to run one. That would be cool, but not a Big Bang on it. So you have your a Z22. Okay. Throttle by spacer, injectors and plugs and wires, Cannon filter. I think that's the plan. 16-inch torque thrust. Okay. I figured V10 Ram truck engine since they're in junkyards. I've seen a couple of those, but that's a different engine than a Viper engine. Unless you find an SRT10 truck in the wrecking yard, which would be really rare. The V10 I want to run is the Ford one. Cutting the guides down, which cam would you suggest for the Vortec 454, the 288 with the lower lift, more duration, or the... I don't think you can get away with the 288 with available piston to valve clearance. I don't think that cam works. I think the 288 was as big as we've tried. And what are you trying to do with it? Forget about whether the cam fits or not. What is your goal for the motor? What thing or things do you want it to achieve? and then we can decide on a camshaft. LS 4.8 liter rod cap and crank cap torque specs. Yeah, all that stuff is online. There's a torque sequence for those. It's an angle torque. It's just a motor to play with until I can do my frame off and I can afford pump gas. So because you have to afford it, you have to put pump gas in it. 750 horsepower motor dressed up as a stock 375 horse 396. That's cool. The Triton V10 is a high capacity spark plug shooter. Has anybody ever actually had that happen to them? I've never had that happen on any sort of modular Ford. All you have to do is put in, Corey, if you just go to your search bar and put in LS rod bolt torque sequence, LS main cap torque sequence, it comes right up. Tim, what's going on? Tim, by the way, I did a pizza today, and as always, it was awesome. But my wife brought home buckhorn steak, which was even, well, I guess tri-tip, which was even better. What's the current junkyard preferred choice for factory big blocks? For big block Chevys, it would be a Gen 6. A Gen 6 and a Gen 5 are the same price, and a Gen 6 is a way better motor. It has better heads, it's a hydraulic roller. If you were going to keep the factory EFI stuff, it has a better EFI setup. Corey, you'll find that stuff online too. You'll find if there's a conversion for that. It's not a direct conversion like that, but you'll find one that works good enough. Everybody drag racing an electric car? Yeah, there's lots of guys doing that. I'm off to work in 20 minutes and then set lash on the small block and enjoy a few beverages. I like that. Got to set a goal. Ryan, so you have aftermarket pistons? I think you'd have to with the 239 cam in it. Jet, you guys, the big blocks didn't come over to Australia? A pump gas rebuild to make close to 1,000 with twin 66s. You could go buy one from Nelson Racing. Two more days before whiskey. T minus 2 days or W minus 2 days. EVs have traction control. Yeah, if you look at a Tesla Plaid, it's a seriously capable car. It gets off the line like nobody's business. They're cool to ride in. So I've never ridden in a Plaid, but I've ridden in other Teslas, and I've driven one or two of them, and it is neat. It's just not for me. I don't think that electric cars are the way to go. Did you talk with Calvin when you're doing? I've talked to Calvin quite a few times, him and his dad. It's a Gen 6, okay. Electric engines will eventually dominate racing. You think an electric engine will beat a top fuel motor? That's everyone has to go see a top fuel motor run. They're impressive. They shake the earth, it feels like. Would you pick a higher PM NA big block over a blown big block for a 900 horsepower street strip Chevelle? 54% are saying no. We're a little bit more yeses on the boost. A Trailblazer SS with a crate engine on it. If you have 821 heads on it, it's not a Trailblazer SS intake manifold. If it has 821 heads on it, it's an LY6 intake manifold. It's a cathedral port truck intake manifold. Technically speaking, a Trailblazer SS is a cathedral port intake manifold, the later cathedral port intake manifolds. But 821s are rec ports, so that's a different intake manifold. Top fuel, you feel the vibration outside the stadium. One, what's faster, electric conduction, or explosions? You're asking a simplistic question to a complex equation. That's not the answer. You just want to generate an answer so that you can say one is superior. But my question isn't that. My question is which one of those goes down the quarter mile quicker. And right now, electric isn't doing that. Is 2.5-inch ID crossover piping too small for the hot side of a 1500 horsepower on a single turbo LS? That's not what I would use on a 1500 horsepower setup. I would use something bigger than that. I don't have any testing for tubing size at 1500 horsepower. I just feel like that's not enough. I took my F2 Pro Charge 427 small block powered 69 Camaro out for a drive today. Nice. Much more than 30% throttle in first. I'll hit the rev limiter. Top fuel won't be beat by electric for a while. Love to build a 500 Cadillac for one of my trucks. They are very, very torquey. That was a fun experience being out with Scott and Corky out at Cadco and being there with all that Cadillac testing. That was a fun deal. It's cool doing stuff with guys that specialize in something, and then I can go there and learn from the guys that obviously know more than I do about a specific application. Pretty cool. I liked being there with the Cadillac stuff. I assume the same. I'd like to see a test on big horsepower single turbo setups with different crossover piping to see how much it would affect output limits. Yeah, I'm not going to be doing any testing like that. I'm not going to be doing 1500 horsepower crossover testing. Unfortunately, I think that the market for that is very, very tiny. I don't think that's a question that people really want answered because I think that they're all just going to go bigger. Would the truck Norris camshaft work or the sloppy stage 2 on an LQ9 with 821 heads? Yeah. Any camshaft that you can think of or name will work on that motor. Any LS cam, any stock one, any aftermarket cam, they'll all just go in there and do what they do. They don't care that it's a 6-liter. They don't care that it has 821 heads. They'll just make the power that they make. The sloppy stage 2, if you look at the video that I have up comparing those two specifically that you mentioned, the sloppy stage 2 makes more power on the top. The Truck Norse made more power up to about 5,000 compared to the sloppy stage 2. Sloppy stage 2 was much softer down low. And that's exactly what would happen on an LQ9 with 821 heads or a 6-liter with cathedral port heads or any combination. Those camshafts are going to do that. Where that crossover point is and how much the difference is and where they stop and start might be, start and stop at a different point. But that's what's going to happen with those camshafts. Can the flow of current react faster than the explosion is? I think you'd have to narrow down that question to specific engine speeds. Do you dabble in small engines? I have a GoPed. In fact, I have a really small engine. I wish I had it here. It's from... It's a replica, a small replica. It's about this big of an inline 6-cylinder that I'm building. And as soon as I get the rest of the parts for it, I'm going to put it all the way together. So that's pretty little. But yeah, lots of, I have a 3-cylinder Metro and not small like that. Not mini bike engines. Is there a hot side diameter that would be too large? Yeah, I think you could get to the point where you would have volume. I think that on a single turbo, I think when you start looking at the size of the tubing relative to the size of the feed opening for the turbo itself, I think we just use common sense there. So I think if you had 2 4-inch tubes necking down to 2 3s or 2 2.5s or whatever the opening size is to feed the turbo, depending on whether it's a T6 large frame, mid frame, T3, whatever it is, I think it could get to be detrimental. If nothing else, I mean, guys would argue about, oh, you're having a hard time filling all that volume. You could talk about that, but also look at the way that it would have to neck down to the turbo. That could also be detrimental, I think. Texas Beach Chupacabra Truck Norse are more of a torque cam. If you want more high RPM range, you might need something different. Does anyone make a blower intake for a Gen 7 496 for 8.1? I don't know if somebody does or not. I haven't seen one. I have a big block Chevy here in my shop that has 8.2 cast into the side. Not sure exactly what it's from. Came out of a Vega that was a drag setup. Did PSI or one of those industrial ones make an 8.2? They made an 8.1. They made an 8.8. Did they also make an 8.2 that I'm not aware of? What's Nathan? What size are those T6 openings? I can tell you on the Nathan, on your question on the tubing size, maybe 2.5 isn't a problem. If the opening is less than that already going into the turbo, maybe that's not an issue. Never mind, it's a 502. That would make more sense. See, look at that, problem solved, or question solved. 502 is that's a good one to have though. $502. It's like 409, but a little bit more modern. We got one more minute. Yeah, Nathan, I can't remember. I have a T6. The Summit S475 is a T6. I just don't remember what size those openings are. So I wonder if like, let's say the tubing size, because if it's a divided one, you have two of them. Let's say that you have essentially two 2.5s. If you made the rest of it 2.5 coming out of the exhaust pipe, is that going to be restrictive if it ultimately has to go down to 2.5 anyway? I don't know. Any 48.8 rear end experts in here? Adrian wants to know. 502 is known as the GMPP Ramjet 502. There are other 502s that they sold too, right? It doesn't have to have the Ramjet fuel injection on it. They had carbureted 502s. They were all aftermarket. They were not factory 502s. Not in production vehicles anyway. The stop stage 2 work with a supercharger. Yes, any camshaft works with a supercharger. The camshaft just does what the camshaft does, and then any sort of supercharger that you add to that just adds boost on top of that. So pick the cam for where you want your motor to make power and how much NA power you want it to do, and then add boost to that. What's the draw of a dry nitrous kit versus wet? So West builds, yours will be the last one. A little bit of a complex answer. Dry nitrous setups work better. Like, for instance, if we were going to run nitrous through an intake manifold that's designed to flow air and not fuel. So all of these LS intake manifolds, the Coyote, all of these, the problem with trying to flow a wet setup, which is nitrous and fuel injected together, the problem with trying to flow that like with a nozzle or whatever, a fogger nozzle in front of the throttle body and blowing that into the intake manifold, the problem with that is the fuel doesn't want to follow the tortuous path that it has to go to get to all the cylinders evenly. You can run small shots on that and it seems to work pretty well. But once you try to go to big shots, you have a big disparity in the air fuel ratio of each individual cylinder because the fuel can't get to all of them evenly. If you run a dry setup and you're injecting just the nitrous into there, it gets a little better, and then you add the fuel through the injectors. The other thing that doing that, adding the fuel through the injectors, it adds the fuel in a more timely manner. The nitrous always seems to get there first before the fuel does if you inject them both together. But the downside potentially is if you're injecting the extra fuel through the injectors, you're taxing the amount of, you have to have enough injector to be able to do that. If you're adding 100 horsepower or 200 horsepower, you have to have the additional 100 horsepower to add, of fuel flow from the injector. When you're just adding fuel and nitrous through a fogger nozzle, it's just a fuel line run over there. And so it doesn't affect the fuel flow of the injectors. 75 to 100 shot. No, that's fine. It depends on the shot size, whether it's big or not, depends on what motor you're putting it on. If you're putting 100 shot on a motor that only makes 100 horsepower, that's a big shot because that's 100%. If you're putting 100 horsepower on a motor that makes 400, that's like 25%. That's not really that big of a shot. And on that note, it is time to go. But I will see you guys all tomorrow. Tomorrow.